have that title.
100%. Good evening, everybody. Welcome back to another episode of Let's Talk Lake County. I'm your host, David Rich. I have a very, very special guest on who's a recurring guest on my other shows. And now on this one, Dr. Mary Ruwart, who is a PhD in biophysics, and there's nothing to trifle with there. That's a very formidable accomplishment and title. She was also she worked for a pharmaceutical company for 19 years. Is that right?
Yes, that's right.
Yeah. Okay. So you're the real deal, and we've talked before about a multitude of different things. I think we talked briefly about vaccines. I don't remember, but we're going to talk about vaccines today because she has a very informed perspective on this, and so let's go wherever you want to start with that topic.
Okay. Well, so when the vaccine came out, I did not take it. Because I knew there were only 2 months of safety studies, and I know from my pharmaceutical background that we generally test a lot longer than that. And of course, this was a whole new technology. And so I was hesitant, and I didn't take it. Plus, I felt like I could weather a COVID infection. I'm relatively healthy and don't have comorbidities, so I figured I'd survive it, and then I'd have better immunity than anybody, because that's the best immunity of all, is when you actually get the disease. And as it turned out, I think that was very fortunate I did that, because I think if the data is allowed to come out, I believe that we will look back on the COVID vaccine and the way the mRNA vaccine for hundreds and thousands of people, millions, I guess, really, was put together, that we will consider this probably the biggest pharmaceutical snafu in history. So that's my brief comment on that, and we can get into more detail if you and your listeners would like.
Yeah, okay, and just so viewers know that there's a comments section up there on the right if you want to, ask any questions or give any comments, concerns. Please do. Yeah, no, so and I think I do remember now we talked a little bit about this, because I remember I said, like, I interviewed you on my radio show specifically about vaccines, now that I remember. And it was during the COVID situation, and like, I was getting so much. I'm not a doctor. I mean, I have a master's degree in systems science, but that's not going to be able to get me to understand like medical anything. I can understand scientific lingo a lot, and I kind of do a little bit better than most there. But like, I heard like yourself say certain things, and I heard other people saying other things. I'm like, I don't know. I don't know what to believe. And it was like, everything was unraveling and rolling out so like rapidly and like hastily and with like this dire sense of urgency and everything else. Yeah, so I did get the vaccines, and hopefully it won't have any negative effect on me. But I did notice that when I was watching your lecture the other day, you did mention that what happens in part is that when you take the vaccines, it actually diminishes the efficacy of your natural immune system.
It can, yes, it can. And this is what a lot of immunologists were afraid of. But actually, you can overstimulate it too. And that's kind of what happens if you keep getting the same vaccine. And then what ends up happening is, because your cells of your body are making the spike protein, your immune system can think that it needs to attack those cells. And that's what happened, I think, to a lot of people. But I think maybe to help, obviously the lay people, your listeners here, understand what's different about the mRNA vaccines, I think it'll be very helpful. When we get a normal vaccine, we are getting a measured amount of the antigen, which antigen is the piece of the virus that you get in a normal vaccine to stimulate your immune system into recognizing that as foreign. Well, the problem is with the mRNA technology in general is you are not getting a measured amount of antigen. You are getting a measured amount of the directions to make the antigen. And the problem is that depending on a person's health, depending on their genetics, depending on what they're eating, or other environmental factors, every person will make a different amount of the antigen. So essentially, Yeah, you don't know what dose you're taking. It's kind of like if you took a painkiller drug, an opioid that the pharmaceutical company made, you'd be getting a measured amount of that opioid. But if you buy it on the street where they cut it with different things, you're getting something that's a dose you don't even know what it is. So that is the kind of difference with the mRNA technology and regular vaccines. I mean, there are other differences, but that's the big difference. I think that makes the difference. And although I haven't gotten data on this per se, I have noticed from the data that different countries put out, like Britain put out data for their elderly, and it turned out that the vaccine didn't help the elderly at all. And I think that's partly because as we get older, we're not going to make the antigen. Our body's not as healthy anymore. But if we have younger people taking it, their healthy bodies are going to make a lot of the antigen. And, you know, the antigen is toxic in this case. It's a spike protein. It in itself is toxic. And this has been demonstrated quite elaborately by many laboratories. So basically, you're instructing your body to make a toxin of an unknown amount. And some people have made it not just for a few days, but they've made it for 6 months plus. And in fact, I think, I haven't read this paper yet, but I have heard there's a paper out that says that people who have taken the vaccine can be making the spike protein for years. So this is bad. And the thing is, the reason is because you're not actually getting regular mRNA. The mRNA that your body makes, and every cell in your body makes it, it's very fragile. It only lasts for a little while. But when they made the mRNA vaccine, they took apart a piece of the mRNA building blocks called uridine, and they fixed it so your body had a difficult time breaking it down. It's called pseudouridine. And so that's why this stuff stays around for a long time, which I don't think was the safest thing to do. Because now, again, depending on your body, depending on your health, your environment, your genetics, you're going to break down the spike protein at a different rate than your neighbor, possibly. You know, so everybody's going to do that at a different rate. So there are a lot of uncontrolled variables here. Also, you know, the idea that it stayed in your arm was incorrect. And the thing is, they knew it was incorrect because studies had been done in animals with radioactive tracer. And what they found is that tracer pretty much went everywhere. And that's not surprising because the lipid nanoparticle that they put it in was actually a drug delivery technology for cancer patients so that you could put chemotherapy in that nanoparticle and it would go past the blood-brain barrier. And the blood-brain barrier is kind of a special biological thing that protects our brain. And I'm just saying that for listeners who might not be aware of it, you know. So the brain is protected by this extra barrier, and you don't want to break through that unless you really need to. And for example, if you had a brain tumor, then maybe you'd want the chemotherapy to go in there. And you would use something like the lipid nanoparticle. And the lipid nanoparticle, as well as the spike protein, turns out to have its own toxicity or inflammatory component. Many people have heard about the fact that if you take inflammatory drugs or inflammatory foods, you can actually have a big problem. And, you know, you don't want to have that big problem, you know, because you'll have to take either synthetic anti-inflammatories or a lot of natural ones. And of course, that means your body is busy doing that instead of doing what it should.
Right. Right. Yeah. Interesting. Yeah. Like I know that one thing, and this is just a problem with like statistical averages in general. Like, you know, statistical averages by definition do not represent every individual within the data set, if you will. They have, you know, here's your, you know, mean average, and then you have outliers, and these outliers are not covered. I mean, I know that according to my pharmacist that, like, you know, in order for a drug to get okayed, they just do 2 standard deviations away from the mean. And I think the first one's 68%, the second one jumps up to like 95, but then after that it's okay. But if you're testing like 8 million people, yeah, that 5% that's left over, that's a lot of people. that you're not
Exactly.
counting, you
Well,
know, and
exactly.
yeah,
And
and
that's
so
when you get a measured amount of the drug, right? A measured amount of the antigen, and So what happens when it's just the instructions and you don't know how much your body's going to make?
right, and that's really interesting. Then, like again, going back to like the averages do not represent all individuals. Like, what if you're one of those individuals on the outliers? Like, and I brought this up with my GP, and he, whatever, he didn't even know what I'm talking about. But I'm like, well, like, because I supposedly have type 2 diabetes, and like all the blood tests and the meters and everything say I do, but literally for 14 years since I've been diagnosed, I have not experienced a single symptom. I mean, nothing. I feel great, no brain fog, no fatigue, I don't urinate a lot, whatever else it may be, no dry skin. I mean, nothing. All I have are the numbers on a meter. I'm not saying I don't have it. I believe the meter. But what my point is that even if I somehow fall within the statistical category of having type 2 diabetes, that doesn't mean that it's affecting me exactly the same way it's affecting other people. Some people are losing their limbs. I mean, I'm nowhere even close to that, I don't think. That kind of thing. So like I don't know how else they would do it because the industry is so generalized. That like how do you like attend to each individual and say, okay, well, this is do have diabetes, but it's really not having a negative effect. Go ahead and eat popcorn. Like, you know what I'm saying?
Yes, yes, and actually, to address your concern about this, or you're trying to figure it out, if you wear one of those continuous glucose monitors, you can find some very interesting things. Like for me, what happens to me is I go to sleep at night, my blood glucose drops. If it starts getting into the 80s, lower 80s especially, my body doesn't like that. So what it does is it puts out adrenaline or corticosteroids or some type of stimulant. I don't know what it is because I've not been able to measure it. But when that stimulant starts, it's a stimulant that will release glucose into my system. So all of a sudden, instead of having this nice steady glucose, it's going up, up, and then about this point, I wake up, because there's so much of this stimulant in my system, and it takes me a while to go back to sleep. And so what I realize is that when we do fasting glucoses, which is what normal doctors do in order to diagnose their patients with diabetes, and it's 110. Well, in my case, I can be way down there just before I wake up, but 30 minutes later, after I get that stimulant in me, I wake up and lo and behold, I could have a higher glucose than I did half an hour ago. So, our technology, what I guess I'm trying to say is, even though a lot of people think that the medical doctors know so much and everything, and they know more than the average person. But the problem is, we've just scratched the surface of biology. We're at about the 5% mark. We're not at like the 50% mark. We're not even close. So what's going to happen, in our lifetimes, even, is we're going to see that a lot of the things we thought were correct about medicine probably are not. And in fact, that's what the medical students say. Basically they learn a whole lot of different things than the classes before them learned, because our biology is extremely complex, much more complex than most people think, and that includes the doctors and the people who try to get drugs made that will help people, all in good conscience. But there's so much complexity, and we've just talked a little bit about the COVID vaccine complexity. I've just really gotten started, but I don't want to overwhelm you and your listeners either. So that's the important thing to remember about biology. And you're right to look at how you feel and say, I feel pretty good. Well, you probably do.
Really good.
Yeah, you can't feel, if you feel, it's when you start feeling bad or fatigued that you go, maybe I need some help here.
Right, exactly. Yeah, I mean, last time I did my A1C, it was dangerously high, but like my GP, like he's like, you're gonna like lose a limb and blah 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 blah, and henny penny, the sky is falling. I'm like, okay, so I did some research. It turns out like 0.8% of people with diabetes lose a limb. I'm like, dude, if you're reasoning that way, I'm having a poker game. You come on over and you keep thinking that way statistically and bring lots of money, because if something has a 0.8% chance of happening, it's a 99.2% chance it's not going to happen.
Yeah. Well, okay. So, another thing to think about, though, and again, this is where our biology complexity plays in. If you feel like you have something like diabetes going on, and you're not feeling good, one of the things to think about is that caloric restriction is the biggest longevity medicine known. And this is one of the few things that the longevity people all agree on. It's hard to get scientists to agree on stuff. And now the trick is you have to eat about 80% less. I'm sorry, 20% less than the food you want. In other words, you eat 80% as much as you want, but you have to eat good quality food. You can't just eat, junk food all the time and expect you to live a longer life. So that's hard because we love to eat, right? and
Yeah, no, I'm Italian. I very much love to eat.
yes, it's,
Yeah.
it's really hard. But anyhow, that's if you one of the first things you can do if you start feeling crummy is see if caloric restriction helps you, because it does put you in you put your body in a state where it's easier to heal itself too. So that's something important. The body is actually pretty resilient
Yeah.
if you give it the
Yeah.
right stuff. So that's just like a little tiny piece of the puzzle, but something I'd start with.
Yeah. Okay. No, that's very cool. No, I mean a healthy lifestyle, including a healthy diet and whatever exercise or just not being sedentary, is a very, very pivotal part of overall good health.
That's
I
right.
don't know anybody who would argue against that, but but you're right. I mean, I when I was doing my bachelor's degree in philosophy of science, I mean, one of the things that we talked about a lot, like in epistemology, was that reasonable people disagree. And so scientists are reasonable people, highly educated people, but they don't always agree. And that to us, to the people in the public, it becomes frustrating. Well,
Sure.
is it this or is it not this? I mean, that kind of thing. Well, one person says it is, the other scientist says it's not, and like, okay, I don't know. Like with the vaccines, I'm like, I don't know what to believe.
Right. Well,
You know,
so the bottom line is you just have to wait it out and see what finally pops up, and that's why censorship is that we had during COVID was so dangerous. It
oh yeah,
prevented us from getting to the bottom line of what was going on and what needed to be done very quickly. And this is in part because the FDA's salaries, the part of the FDA that approves drugs, are now paid for by the pharmaceutical industry from the Prescription Drug User Fee Act of 1992. It used to be a small charge of $100,000 that the drug companies could pay to the FDA to hire more examiners so that their drug could get approved more quickly. Now it's something like 3 something million. And I believe it's not optional anymore, although I'm not sure of that. I think companies pay it because if they don't, then their drug goes to the bottom of the heap. When 74% or so of the salaries are coming from the drug industry is going to get a break, and that's why Vioxx got put on the market. The FDA was warned by one of their own examiners that this drug causes heart attacks. And the person who told the FDA boss that was told, well, the pharmaceutical companies are now our client, so we will approve it. And of course, as a result, it had to be withdrawn because of all the heart attacks.
okay.
And that's, I think, what happened with the COVID vaccine, too. There were a lot of red flags in the material that Pfizer submitted to the FDA, and probably Moderna, too, although I haven't read the Moderna stuff. I have read the Pfizer submissions to the FDA for the most part. And they were very careful how they put things. They said, we did not test for transmission. We don't have any idea if it's going to prevent you from, infecting your neighbor. So, yet the government agencies kept telling us that it would. So, in part, we got lied to, and
Oh yeah.
in part, and of course, not only did we get lied to, but things that could have helped us were censored, like the ivermectin, hydroxychloroquine. So, it's just been a total mess. And I think there's been a lot of falsification of data. And so I don't know if we'll ever know every single detail. But and you guys probably know Biden extended the immunity for the pharmaceutical firms that made the vaccine until 2029. And The only thing I think that could overturn that is fraud. And there are some things in the Pfizer document submission that could be construed as fraud. So that might happen. I don't know. I don't know if obviously it starts getting pretty technical, right? So it just depends if the Trump administration understands these nuances and decides to do something about it.
Yeah. Okay. We'll see. We'll see. I want to go back real quick to like the complexity of your body of biology, because you know the system science. I have a master's degree in system science, and it used to be called complexity theory. That was what it was called before it was called system science. So we attended to and dealt with complex systems quite a bit, the analysis thereof, and so on. One of the most difficult things to do in any complex system is to predict an outcome. Predictability is very, very difficult. There's some. I was just reading some guy about. He gave the analogy of like, let's say you're standing on top of a hill and there's like ragged rocks and like spikes and everything else, and there's a heavy wind, and you have a basketball and you throw it down the hill. There's absolutely no way of you predicting what's going to happen to that basketball. Absolutely none whatsoever, other than it's going to go down, because there's just too many determining factors, variables involved in that pathway down the hill. So, and then that's just a mountain, you know, like what our bodies are like, what, 300 systems working in unison or something like that, separate systems.
Probably
I don't
more
know.
than that.
Probably more than that.
Probably more
So predictability is very, very difficult to do. But when it comes to medicine, that's exactly what you're doing. You're saying take this and X, Y, and Z at least should happen. And when it doesn't happen, or only Y happens and not X and Z, say, your prediction has failed. And I don't know you know, if it can count as good science when you can't make a prediction worth a darn.
Well, even
Right?
even when the what they call the randomized placebo-controlled trials show significance, sometimes that significance is not what we call clinically significant. For example, let's say that if you give a drug that's supposed to lower blood pressure to 10,000 people, and all of them have their blood pressure lowered by 2 millimeters, which is a really small amount.
Right. Not much.
And it would be highly statistically significant, but it would be what we call clinically insignificant because that's just too small of a drop. And that's one of the problems with these, randomized placebo-controlled trials and looking at statistical significance. Because on the other hand, if you gave 10,000 people a drug that was supposed to save their lives, and it saved 1,000 lives, it probably would not be statistically significant, depending on, exactly how the statistics were set up. So, and this is something that I think was the NIH. I may be wrong on the government agency here, but I believe it was the NIH that recognized this and several years ago started trying to figure out which trials might have that distribution where it's helping a small number of people, but it's really helping. So I don't know if that ever really got off the ground. I reference it in my book, Death by Regulation. So, I mean, I guess I could dig it out if somebody really wants to find it.
Yeah, no, I read that book. That's a great book, everybody. Just by the way, Dr. Mary Ruwart, Death by Regulation. Definitely something to read. Very informative. Yeah, you want to talk about regulations real quick in the medical industry? I mean, you're a libertarian, and just ideologically, kind of like don't like top-down authority, and I don't either. And that but the moral underpinning of that is like everything's like, oh my God, we get rid of the federal regulations and everything's going to go straight to hell. Is that doctors and medical scientists or scientists in general are, at least generally speaking, attempting to do the right thing, and they know better about it than the federal government does. So to put arbitrary regulations on different industries, markets, what have you, businesses, is probably just a complete and total waste of time. Like, if the regulation is like a good one, I'm sure that the markets or industries or businesses you're putting it on already know that. Like, we're already doing this because we know what we're talking about, right? I mean, would you speak to that at all?
Yeah, actually, I, according to my calculations, which I've gotten death by regulation, as you know, I figured that about 80% of the money we spend on regulatory, um, satisfying the regulatory agency, the FDA, about the drugs, about 80% of that doesn't increase safety or effectiveness at all, and is basically a waste of money. So, 80%, we'd have a lowering of about 80% of our costs that we pay at the pharmacy if we didn't have those regulations. And that's actually true for almost every regulation. In fact, there's been several studies where they've compared states that have different regulations for electricians. And what happened is the states that had the most stringent regulations for an electrician license also had the most um, electrocutions.
Oh,
And you might say, wait, that doesn't make sense. But if you think about the economics of it, it does. So what happens when you have all these regulations or more hoops that people who want to be electrician have to jump through? Well, there's going to be fewer people that jump through all those hoops. They aren't going to have the money or the time or the wherewithal, or even the desire to spend all those years jumping through all those hoops. So, in other words, there'll be fewer electricians in that state. And because there are fewer electricians, what happens is that the price of those electricians, the prices they can charge, go up. So then the people who are not very well off can't afford them and don't call them in when maybe a repair is needed, or they attempt to make the repair themselves. And so that's why regulations tend to be quite literally overkill. And that's even true for the FDA regulations. Even when the regulators are trying very, very hard to just make sure they only approve safe and effective drugs. And I've actually presented some of the data in death by regulation quite a few years ago, about 15 years ago, to maybe 20 years ago now, to some higher ups in the FDA. And they're well aware of this. They're well aware that if a life-saving drug is kept off the market so it can jump through all these hoops, that people will die waiting. And of course, again, in death by regulation, because there's been so many studies, I was able to take those studies and compile them and do a rough calculation of how many people have died waiting for life-saving drugs. And of course, not all drugs are life-saving, but the ones in the period that I studied probably were closest to that. And, basically, when you spread it out over the population, those regulations have cost each of us about 5 to 10 years of our lives. And that's pretty scary.
Oh, that's a lot. Yeah. Wow. Holy cats. Wow.
I mean, and I think that's a conservative estimate, and of course, time will tell if that is indeed true. I think the drugs that we're getting now are very different quality than the drugs we used to get, because these regulations aren't like static. They increase every year. And so the cost of getting an FDA approval increases exponentially every year. So it's just going to get worse and worse until finally the system's broken, which it's getting pretty close to now.
Interesting. Well, that's disconcerting at best.
Yeah.
Yeah. Okay. All right. But okay. So about vaccinations, you're not generally opposed to all vaccinations, right? You just think that we're kind of overdoing it. Okay. Some are good, but we got rid of polio.
Yeah. When I traveled to India several years ago, I got vaccinations. Although I have to say, what all this COVID vaccine stuff has brought up is it's made people look at the actual vaccine schedule for our children and which hoops the vaccine have to jump through. And what it turns out is there are almost no placebo-controlled trials in the vaccine space. What they do is, instead of having a placebo, which is supposed to be pretty much inert, they use another vaccine that's already been approved. So if that vaccine has pretty horrible side effects, when you compare that vaccine to the new vaccine, they'll look the same. And
what do you think you're gonna get? Yeah. Oh my. That
I mean, it's
sounds
really
okay. That
messed
sounds
up.
like a bias in your trials. I mean, that's no.
Yes, well,
Mm,
yes. So I don't think this was common knowledge until, basically the COVID years, because, like I said, people started looking pretty closely at regular vaccines as well. And so, whereas, I don't know, what was this, 8 years ago, maybe I went to India, something like that. I mean, I would be more hesitant today, especially, and if it's mRNA technology, I just wouldn't do it.
really interesting.
And
Okay.
I want to mention one other very important thing that I think your listeners should know, and that is, when the COVID manufacturers did their clinical trials, they did it with a different manufacturing process than they used for the vaccines that went out into the general public. And this second manufacturing process is supposed to be vetted by the FDA. And the FDA has certain rules about how much contamination of DNA particles you can have in products that you're going to inject or take. And they recently came out after independent scientists already proved this. They recently came out, the FDA, with a paper saying that in the COVID vaccines, there was 400 to 400 times as much DNA in those vaccines that it was supposed to have. Now, your listeners may be going, "Oh, do you mean messenger RNA?" No. So DNA itself, of course, is the genetic genome. It's your genetic code. And what they did to try to get rid of this DNA is the manufacturers used a special protein that chewed up the DNA. So now it's little fragments. And those little fragments are more easily to incorporate in your own DNA than than it would be if they were still in the whole state. And so that actually made it worse. And we don't really know how big of an impact this is going to have, but it's in violation of the FDA regulations on how much DNA is allowed in any pharmaceutical product.
Wow.
It's not meant to manipulate your genome or your regular genes. I'm trying not to get too technical here, so if
Right. No, I mean, no, I think it's
have a
most
question,
people understand vaguely what a DNA. Yeah, I think most people at least vaguely understand what DNA is, kind of like your physical essence, if you will. Um, so yeah, okay. Well, that's really interesting stuff here, and there's so much more to talk about with this stuff, and we don't have the time to do so, but
right?
um, you know, um, what do you think the next? What would you want to say to the general public concerning vaccines in the future? Outside of pandemics and everything else,
Yeah, yeah.
flu shots and stuff like that. Good idea, bad idea?
Yeah. Well, before COVID, there was a study of the flu shots, and what they found is that our soldiers who had the flu shots were more susceptible to coronavirus infections. This was a big study,
Jesus Christ.
and I think it came out. Don't quote me on this, but I think it came out in 2017 or something. It was a couple of years before COVID, and when people pointed this out, scientists pointed this out, because the CDC was recommending you get the flu shot and the COVID shot at the same time, and they were worried. People were worried, and they tried to poo-poo the study, but it was done by the VA, another government agency. So, and I thought it looked pretty good, and there was no reason there was no reason prior to COVID to knock that study, and nobody did. So, and there's nobody that I heard of. So, I would say be careful, especially with there's a push now to do all these mRNA vaccines, and I personally will not be taking them. That's all I can say. I'm not a MD, so I can't advise anybody of their health, choices. But I personally will not be taking mRNA vaccines. I think we have a long way to go before they're safe, and they may never be safe. And I think certainly with that pseudouridine in there that makes the antigen lasts longer in your body, I think that's very dangerous, because if your cells are manufacturing it and they keep manufacturing it, your immune system is very likely at some point going to say, oh, these cells are all foreign, and they'll attack. So then you'll have autoimmunity issues, which is not good.
No, autoimmune is an awful thing. Yeah, for sure. Oh, I know a couple of people that have it, and that they are not doing well. I know one lady I went to high school with. She's probably on her way out, to be honest with you, because of it. She's awful. I mean, she's a great person, but her condition is awful. Yeah. So, okay. Well, did you anything else you wanted to highlight?
Well, I guess one of the things I'd say is really the key is trying to make yourself as healthy as you can. Then if you end up having an insult like the COVID vaccine or an environmental toxin or whatever it is, you're going to be in better shape. And one of the things that came out of the COVID crisis was the recognition that it's very, very important to have much higher levels of vitamin D in your system than we thought in the past. So, I guess I would suggest that if you are interested in this kind of stuff, that you look into nutritional options. And the place I like to, if I'm going to advise somebody to look at like a one-stop shop for information on such things, I do like Life Extension. So lifeextension.com is the website. And the nice thing is they have a lot of free information there. So like if you're searching diabetes, you can read about a diabetes protocol. And actually, you can freely consult with some of their experts on what they would advise after they look at your blood panel. And you can get the blood panels. Usually they're like there's a big sale on them in the early summer. So you can get them done, then you can get some advice. And, if you want to go that route and you're feeling like, gee, I don't know enough about this stuff, you have a place where you can go and get, I think, the best information that a lay person can get in understandable language. So highly recommend it. And in fact, Bill Falloon, one of the founders of Life Extension, he and his partner ended up getting prosecuted by the FDA. They tried to jail them for life because they brought coenzyme Q into the US. And coenzyme Q is something your body makes naturally. In Japan, it was being sold as a drug, which is why
it's a prescription drug in Japan. Like like, do we know something they don't? I mean, yeah, okay, go ahead.
Well, no, I mean, what happens? So what happens if you're taking a statin and you're having muscle weakness? Generally, your doctor will prescribe coenzyme Q if they know about it. In fact, if they don't know about it, they really should. You might want to, look elsewhere for your doctor. But so a lot of the muscle weakness that comes from statins is because when the body breaks down the statin, so your body will excrete it, it requires this coenzyme Q to do it. And so the coenzyme Q basically gets eaten up by the process, right? So your stores of coenzyme Q or the coenzyme Q your body's manufacturing basically plummet. And at some point that creates a problem with your muscles. So, but the Life Extension folks, even though they were told by their attorney that they should plea bargain and just plan on spending time in jail, they said no. And they went on the radio, and I don't think there were podcasts at that time. They went on the radio and did a lot of basically infomercials for the public. And the FDA eventually dropped all charges. I think it took about 8 years, though. So that's, I think that was an important landmark, because prior to that time, the FDA was going into health food stores and raiding them and taking all their inventory and things like that. And even my doctor, Dr. Jonathan Wright, who's considered the father of bioidentical hormones for menopausal women, basically, they went in with a SWAT team and held his patients at gunpoint while they raided.
Wow.
And they also did, of course, that to life extension people too. I mean, but that kind of behavior slowed down or stopped entirely once the FDA lost the case against life extension. And I don't know, I just think they might have decided that just wasn't going to be working for them anymore. So
Wow, that's an
I don't know that for sure. I'm just speculating, but
going in, holding patients at gunpoint for over CoQ10. Like, it's, if nothing else, it's a powerful antioxidant. So it's like one of the most powerful ones, as far as I understand. Antioxidants are, as far as I also understand, is very beneficial for you. With all the toxins we have in our system, our little, what is it, like a little electron or something like that goes around the mitochondria track, and it gets knocked off, and like CoQ10 comes in and like makes it all better again, something like that. I'm not sure.
Yeah,
Basically,
and we don't understand it totally either. Again, it's one of those complex biological systems that we know something about.
But not us. There's a difference between knowing something and having a sufficient knowledge of something.
Yes.
I mean, I don't expect any sort of like comprehensive understanding of any complex system, like literally knowing everything. I don't think that's ever going to happen. But you can have like below sufficient understanding. You can have sufficient understanding. You can have higher than sufficient understanding. That's what we should be shooting for. So science is not science if it's not about garnering, credible knowledge. Okay, cool. All right. Well, hey, thank you again, Dr. Mary Ruwart, for coming on the show. Always a pleasure to talk to you and see you. Thank you for all that you do. And I'd like to, again, if you can like get in Chase Oliver's ear, that'd be great. If you, I'm half kidding. But and I'd like to have you back on again to maybe just talk about libertarianism and that kind of thing, because again, I'm trying to like promote third parties through this show as well.
Oh yeah. Of course, I've done a lot in that sphere as well. And of course, I should tell you that the founders of Life Extension are libertarians.
Yes, they were. Yes, you told me that before, which is very cool. I have some supplements from Life Extension. I'm trying to think of what they are now. I do that, or I do Now. You know the brand Now? Capital
Yes,
they do like, they have like third party trials and stuff like that. Certificate thing.
They have somebody measure what they've actually got in the bottle to make sure
that they're not just making up stuff. Life Extension is my second one as well. My other one as well. Both affordable, both great. Have a vast array of products to offer to people. Like Life Extension's got some really wild stuff, like good wild, not bad wild. Like just very nuanced things for very nuanced, specific conditions, if you will. So Life Extension, Life Extension. Just Google it. You'll find it, and it turns out you can get a lot of like credible information concerning the supplements, which I'm going to do literally right after I get off the show. So I'm going to look into that because I'm like, okay, cool. I'm really excited about that. So, okay. Thank you again, Dr. Mary Ruwart, for all that you do. You're a wonderful human being. Always enjoy talking to you. And ladies and gentlemen, thank you for tuning in to Let's Talk Lake County. I'm your host, David Rich. We'll see you next time. Mary, hold on one second. Okay.